Ah, okay, yes, okay, for the recording, yeah, it makes sense. Okay, so once again, Paul Wagner from Deutsche Telekom, the legacy carrier, historical carriers we are known. And well, OCP is sort of a relatively new story for us. We are with the classical telco hardware providers up to now, and we seek alternatives. Well, for the reasons that were already mentioned from other people, that is for flexibility, more responsibility for own products, for create own opportunities, and simply open up the ecosystem a little bit. So let's try to go forward. Yes, oh, yeah. Page up, page down should work, no? No. Okay, so we'll talk with this nice windmill here for Amsterdam. It's the Spanish literary guy that tried to fight against windmills, better give up, it's not of no sense. It's supposed to be funny. Ah, okay. We lost the focus when you did the... Okay. Well, simply go ahead. This is again title. Ah, title, a nice our corporate color. Well, you go a little bit faster. Maybe not too fast. Okay, so why we created a contribution to the OCP telco group. That is the OCP telco group is a community, but hopefully a lot of fellow telco operators, like we heard yesterday, KPN is interested in things like that. I hope our colleagues from Orange and well, for the moment, the official, well, would call it supporters of the idea, so it is Telefonica, for example, and Turk Telekom seems to be very interested in that. Originally, this work was inspired from AT&T, from the famous colleague of Sumitra, from Tom Anschütz, and well, the English people say, you look further if you're on the shoulders of giants, so there were a lot of work done before me, and I simply build on this foundation, and hopefully, well, that turns out to be useful. So the interest is now that we think that shared hardware designs may be good for the ecosystem, will reduce cost, and will be a good thing for innovation, because, well, multiple people can pay for the innovation model, can be involved and invest in the innovation, and then get the whole thing ahead further. So let me see. Okay, so the idea, as I said before, is to have a more flexible access network based on SDN principles. And we were looking around to play with, or to create a network. Well, you need for our purposes, carrier-grade equipment, and we felt that there was nothing out in this disaggregated OCP world that is carrier-grade and fit for our solution yet. Thank you. So yes, the ecosystem, as I said already, leaves room for improvement. There is only few devices present that call themselves PON devices, and those devices come mostly from companies that have not much experience in the telco domain yet. So there's one thing, either you learn about it or other people with experience come into the market. So anyway, we need more players, I think. So to get more players into this market, and we need more Lego bricks to play with. So we're trying to fill this void with a specification that people can build upon to create more of those nice Lego bricks to eventually build good networks with that. So we created a specification for an OLT on the OCP principles. The design guidelines is reuse existing work, as already told. We inspired ourselves from existing designs and existing ideas. We did not want to take anything rocket science, but take virgin silicon, commercial off-the-shelf things, but at the same time very clearly comply to relevant standards. So we are not we are not eager to compromise ITU standards for performance and interoperability in particular. Oops, yeah, okay, it's a little fast, but no problem. We have taken some choices for this design. Well, the first thing is that we clearly target GPON for the moment and not XGS PON as was done with the part of the existing specs right now. Because we think that for the next couple years it's still a very viable solution for mass market access. Because once you know the performance of a GPON, you know that, well, there can be, well, many customers being served with very high performance products, and at the same time, the hardware existing on specifically on the customer side is very cost effective right now. And now, well, there is a good chip generation being available in the market. For the moment, unfortunately, only from one silicon provider, is Broadcom with its Maple Qumran combination. And there's a lot of work being done on the Volta project to get this thing integrated in an OCP well, fashion, so very open. We chose to create reasonable quantity of ports in a single box for the reasons that I will name later, because it's, yeah, okay, continue with that. So redundant power supplies, flexible uplink is something that is relatively new, because up to now the designs were only with a fixed type of uplink interfaces, which would fit nicely to a CO where a cord fabric would be right next to it, but it would not nicely fit to distributed deployment like as we are targeting as classical carrier deployments will always be, because we can't have just a few large COs like or few large data centers like Facebook or so do, and then have well, very, very, very long fiber lines to the customers. This simply makes no sense. So we will have in the order of a couple thousand small COs where the customers are in a range of about 10 to a maximum of 20 kilometers around to cover a whole country with that. Okay, so the two size variants, as I imagined them, and the Lego bricks from the hardware perspective put together, there is visibly two very closely related drawings. The left one is the 32-port version with a quite filled up faceplate for 19-inch 1/8 unit, where you can distinguish a block of 16 PON ports on the left side, a block of 16 PON ports, well, more or less on the right side. Combination of 100G uplink ports, 100G uplink ports in QSFP28 form factor in the middle. And the new thing is that I asked for having the same quantity of uplink bandwidth, that is 2 times 100G in a 2x4 form factor with SFP25, because I expect very soon to have long reach C and DWDM transceivers that I can populate in displays, and then alleviate any kind of fiber restrictions from those many COs, or from those which I didn't mention yet. Fewer COs with large deployments and a cord-like fabric, and many more COs which don't have fabric but just have this access device. And there's a lot of backhaul fiber capacity needed, and this would be nicely fit to such DWDM backhaul possibilities. So on the right side you see another little block. This is the classical outband management. Outband management with a serial console as usual, USB for software installation in the lab, for example, normal, not non-normal deployment. But the new thing is that you have an SFP cage and electrical GigE, which may be alternative. So it allows as well for remote deployment and do a CWM or DWDM remote backhaul for the outbound management. So it go on the right side, we see that it's extremely simply doubling of the downstream ports, the PON ports. There's twice as many SFP cages and double the quantity of PON socks, so it's a system on a chip. And the fun thing is that the idea is to reuse as much as possibility of the same board, the same PCB, and just populate a few more spots on the board and have a twice as large capacity with not much effort. I think the good effects of this will be shown later. So, yeah, next slide. Yeah, that's okay. Oops. So, why this kind of specification is fits well with OCP project and why I'm here is what? Okay, so the things that I mentioned potentially a little bit earlier are now in the OCP10 is the 4 key points to get with such a specification is efficiency, that's particularly valid for the large version you saw on the right side. Scale is, well, both. It's a sufficiently large number of ports in a box, and at the same time scale should be should relate to zero-touch provisioning and to have as little manual intervention as possible on such a box. That is why OCP with those 1 or 2 8 unit box are, well, they're not usually not chassis based in a sense you don't need to change anything. In a normal deployment, just put in a couple boxes and don't touch them anymore. So there's the classical fashion chassis based way was that you deploy as many ports and as many slots and many cards as you just require, and you need to grow them anytime you need more ports. So the idea of OCP is have closed boxes and touch them as little as possible. So next, please. And the very new thing is against legacy kind of devices is openness. We effectively want this thing to run on an open network Linux or something as a NOS that anybody can exchange for the operating system of his preference. If this makes sense for him, no problem, you can do. For a BMC, that should be present, the same is valid. You can choose any kind of auxiliary operating system for the BMC. Unfortunately, openness is a bit restricted or blocked, or well, it ends somewhere when you go towards the chip layer, because the API and SDK layer, which is strictly required, well, there is very little openness up to now, so we would be very eager, and with our colleagues I think we have the same ideas, that this should be a much more open playground for people, even if, well, anyway, you are required to buy some silicon, well, at least let the people implement their software as they like and don't force them into NDAs and stuff like that. So this is a very interesting point about all these OCP things. Well, but anyway, we do not impose with our specification any restrictions. So if somebody wants to create a fully closed software solution, and which is very good and for good price, so why not? It's the basis allows everything. Well, and the last one is this specification is we try to have some impact with that. That should, well, not get tomatoes thrown at me, but simply people saying, yes, this is something that seems a good idea. I want to buy a box like this and play with that and eventually deploy that in a real world. And to be able to deploy such thing in the real world, well, then again, it should be carrier grade. It should not be specific to DT in Germany, but it should be for a worldwide market. The flexible deployment options with the many possible different backhaul solutions. And we have also provided for, which is not that easy, at least the option to have a synchronization to the state of the art to do things like mobile backhaul later. So yes, and OCP, the idea of OCP is specify something that somebody will create hardware out of and later on get some orderable device. And well, the lucky thing is it seems that in a not too far future there will be really something coming out. I did write in the first half of 2019, maybe, yeah, probably that will fit. Will not be in the next 2 weeks. And the interesting thing when there will be other people being able to reply to that just a couple minutes after me will be able to tell you when possibly there's an audible device and not only our first prototype to see. Maybe just one more, please. Okay, contact, always useful. So you're invited when you don't want to say it now because you're discreet or it's you want an NDA to talk about, just write an email to me. Next, please. And that's the nice surprise. This is the first view. Just got it on Sunday. No, on Monday morning. Sorry, on Monday morning. So yesterday morning. This is the first well CID drawing that came from the first company that wants to create an implementation of the specification. And the fun thing is, if you look at this thing, it looks quite a bit like the ideas I had when drawing my first faceplate design. It's just a little bit inverted, but the ideas behind very much are similar to that what I described. So the idea is to have a single PCB that is usable in 2 size versions. You just need to imagine that the PCB is right in the middle, at the middle height of this box, and the lower 32 PON ports, they are just put on the backside, on the lower side of the PCB. And so it's really the same PCB as the smaller versions, or a smaller version for smaller COs, or a smaller version to put it in a lab to have a cheap version to begin with. And well, we can see the backside. The backside is something interesting. Is I talked about efficiency. Efficiency is and lifetime we expect. In contrast to normal well, data center deployments, we expect lifetimes much more in the order of 10 years than in the order of 2 or 3 years for server deployment in a data center for Google or something. For 10 years lifetime, you wouldn't want to have a 40mm fan that revolves at 15,000 RPMs and is howling all day long. It will not survive for 10 years. And it's not really very efficient from the power perspective as well. So the big version has much less fans. It just has 4 fans instead of 6. But those are 60mm and are expected to have a better cooling efficiency for less power and for more lifetime. So that really is what carriers want. Oops. Yeah. Well. This is more or less everything. Did I forget to mention something? Well, you've seen it's Acton Edge Core, the first suppliers of implementation. But the inventation is out there. It's very clear the intention of OCP not to have only one. We want to have ideally, well, 2 suppliers of each hardware. And if other people have great ideas to better this design in some way, to have something as a next generation PON SoC or replace the SoC with an FPGA, as the idea has been put forward by AT&T already a couple of months ago. The idea would be, well, do it. Give us choice. And maybe one thing that was not written somewhere, but is maybe worth to mention, is that this form factor, if you can go one back, please. The same, back, one more. The form factor of SFP for up to, well, a few months ago was limited to GPON, and is limiting, specifically is limited to thermal performance. So those small transceivers were only available up to, or can only dissipate 1.5 watts. And for XGS-PON, that is the 10 Gen G version, you needed to use XFP transceivers because they can dissipate up to 3.5 or 4 watts. And it's quite recently, less than a year, say, that you can get the first implementation on the market for XGS transceivers in SFP size, which means very clearly the next version of this document, which I think we should do very quickly, should be the same size with the next generation of silicon behind, and using the XGS-PON transceivers in the SFP size. So I have the same format of a box, but for the next generation PON, which is again good for flexibility. So I think most things are said. It should be enough potential for questions. Or tomatoes? No? Okay. Yes, please.
I find it interesting that when we start talking about the switches and gear, when I'm trying to get our organisation, we've got a large project, and I'm trying to convince our organisation to go OCP. And one of the things that I see is that the servers and everything can use a backplane, which is 12 volt, or in the case of, well, if we go down like the Google specification, 48 volt. And I'm looking at this footprint here, and I'm seeing you've got standard AC power supplies on the back. Like, is that going to be available in like an actual OCP? Because to me, that's not an OCP device like this, right? So it's really, yeah, because Google, you know, the Google rack is 48 volt for telco. And I'm wondering why this isn't.
So this is one of those issues that have been with OCP from the beginning. All of the switch formats and form factors, and this is somewhat when the network group, right, drives the switch, where this is a OLT or a GPON device, so it's slightly different than, say, an Ethernet switch. Not really, but
yeah, I agree.
right.
Yeah.
So those always had regular, 19-inch aperture, and then with standard power supplies. And so the OCP power shelf has connectors on the back for you to be able to plug in the switch AC cords into those, right? And there's been people who have suggested, hey, could we have a tray that would plug into the bus bar and then take 12 volts in? It's not gotten past really the talking phase. There's not a specification for that I'm aware of yet. Jeff might can help us.
Yeah, I'll take that question. So there's a couple things for OCP gear in a rack. So in the networking group a few years ago, we did introduce a tray that slides into an open rack, so a 21-inch wide open rack. And you're able to mount any standard 19-inch rack mountable device in that tray. And that tray slides into the open rack, connects into the power bus bar on the back, and then we offer, for our products, 12-volt power pass-through modules. So you can plug in effect, you put it in the tray, you connect your power pass-through modules where your AC power supplies would go here. You slide the whole tray in the open rack, and that makes this type of equipment open rack compatible or compliant. part of the issue is for the telco group, though, is I'm not sure how many COs can fit open racks that are 21-inch wide, right? So there is a rack specification in the telco group for CG19, carrier, carrier 19, that has some, I think it's 12-volt power options in that rack as well. I'm not so familiar with that rack, but that takes kind of yet a different design to have that equipment connect to that power bus bar on the back. But for a standard OCP rack, open rack, there is ways to do that. But if the environment is not conducive to a 21-inch wide rack, such as many COs might not be, then for a standard type of CG19 rack or something else, then we'd have to look at other ways to connect into that bus bar.
Yeah, no, that's fine. I thought with obviously, you know, the Google 48-volt version, which is a shallower version, then we'd start to see from the networking group some of those implementations, because, correct me if I'm wrong, but, you know, most telcos that I see are minus 48-volt DC in that, and that leads itself very well to this type of application. Yet I don't see the implementations of the new gear coming out like that, and just curious.
So a lot of the neg 48 PDUs, so if you're using neg 48 into the rack and then converting it to 12, not the new spec for the Google 48 volt, right? But if you're going to convert, you can take neg 48 into the top of the rack, and those PDUs actually have two 20-amp circuits for driving the switches the same way, or actually four, but, you know, two pair for driving the switches a similar way you would drive them if they were an AC power, but then you would switch out the power supply for neg 48 power supplies is the other way of doing it. That's kind of the, you know, standard. If you go down on the show floor, you'll see lots of the, you know, ways that switches are connected to the power.
Yeah, yeah.
Sorry.
But this is the kind of discussion
Yeah,
that is open. So
Yeah.
we need new ideas like this, or desires that a sort of common denominator would be that you get something to order that fits more.
When do you expect to see?
Yeah, this would be.
When do you expect to see this actually being deployed in reality for Deutsche Telekom?
The question is very reasonable, but very simple answer. It depends. As I said, I think the hardware, if you see it like this, looks quite a bit like carrier grade stuff, and I expect to find out about the reality of this very soon. The interesting part is the software part. It makes not very much sense that we have carrier grade hardware, but the software is does not meet our expectations. If we talk about deployment, well, it's not about having a first field trial and a couple people connected to it and get that running. I think this will be very quick. But the idea of rollout means that you can rely on 100% rely on this. And we usually, our customers, unfortunately, we have legacy customers. They are used, for example, in DT, a DT telephone, while you could have it for 20 years and you would learn about a failure or something, a downtime. Well, during that 20 years, you may experience twice a downtime. So they're experienced to legacy reliability. And we can't say, well, we roll out a box like this where the hardware might be able to run for 10 years without a problem, but the software will make it reboot every now and then the people will wait for 15 minutes until they can be reachable again. So we are working very hard on the software part with other people that are present in the room. And, well, we need not only participation in the hardware space to have more choice, but more choice, other people having the same problems will push the software guys in the right direction and get the software live up to the same expectation as we hope to attain here.
I mean, I agree with Paul, his comment from AT&T. This is a very complex, and as Paul said, both DT and AT&T, customer has certain expectation, right? And then given that we are like legacy and the downtime reliability, everything is very important. We definitely embrace like, openness and everything, but we are also try to apply the rigor and discipline that bring us, to the reputation that we do have today, right? So in hope that I think that I'm very happy to see Paul's talk, because we need more, it is one thing that we want open, we want fast, we want, think, but we also want, the most important thing is quality, reliability, right? And that, because otherwise, what good does it do if you get it fast and this thing just fall apart? But completely, agree with, the challenges that like carrier like us face, and we're looking to the community, to help solve this huge challenge. I believe that it is something that can be overcome, but it's not overnight. Yeah.
Many thanks. And, well, maybe we should hand over to one of those guys that are handling the first implementation of the hardware.
Yes, sir. That's a good segue. We're a little over, but I don't think it matters. He'll take it up. But we're ready for the other presentation now. Yeah, on the open GPON, the aggregation router, I think, which is about this, right?
Oh,
No,
you
no,
are not recorded.
Was there a question on the GPON?
Yeah, sure. If there's important questions, go ahead.
I thought you
Anyway.
might want to use that as a segue into the router.
You got my email, so feel free.
Yes.